This tutorial video will cover material creation in Maxwell Studio. We will discuss the physical-based properties Maxwell applies to surfaces and how to use the Material Editor panel. The Maxwell Suite is a powerful engine used by designers to produce a wide range of images, from architectural representation to film and TV production. For this tutorial, we will only use Maxwell Studio. As a reminder, please make sure your entire suite is the same updated version, including all of your plugins. Let's start by creating a new material. Go to your materials list, right-click, and select New Material. A new material will be ready for editing and will appear in your material editor. Now I'd like to talk a little bit about light. Light is essentially electromagnetic radiation, broken down and traveling in different wavelengths. What happens when we see colors is that all waves are absorbed by the material, but the wave that contains that color that we see. For instance, a red object is reflecting back all red waves and has absorbed all other waves. But in the physical world, we do not perceive objects as diffuse or specular, which means reflected surface. What gives objects characteristics such as texture or reflective is the smoothness of its surface. So for instance, the more imperfections and less smooth your surface is, the more light will scatter in all directions. If you had a perfectly smooth surface, for instance, its light would be reflected uniformly, creating a specular reflection of the environment, like a mirror. So let's compare two of my materials here. Metal 1 is a mirror-like surface, because its roughness is 0. But if we come to our wall material, there is a texture to it, which means not all waves are being absorbed in the same way. Because of these imperfections, light is scattering all over. And so its roughness, as you can see, is not 0, it's 40. So it will absorb less wavelengths. This is why Maxwell allows us to alter three main characteristics in a material: its roughness percentage and two reflectance colors. The practical limit of roughness can be considered 95% because no surface is 100% rough. It will always reflect a little bit of light. The reflectance 0 color is the predominant color on the center of our object. The reflectance 90 is the predominant color on its edges. The relationship between these is that the higher the roughness, the more the reflectance 0, or the center color, will dominate. The lower the roughness, the more the reflectance 90, or the edge color, will dominate. Because of this rule, beware when working with texture that your reflectance 90 plus your low roughness might wash out the texture. I will demonstrate this rule using our default material. So this is the default material in Maxwell. It comes in like this. As soon as you open your studio, you might see it. So for me to make it as shiny as a metal surface, for instance, I will lower its roughness to 3. Let's see how the preview looks like. Here we go. Now we have a perfectly reflective surface. Let's now cover the index of refraction. Since Maxwell deals with physical properties, the index of refraction is the number that tells us how light is propagating through a medium. It can be used as an influence multiplier for reflectance 90. For instance, if we make my index of refraction for the default material as high as 30, the index of refraction will transmit light much more. The Fresnel effect is dependent on the index of refraction of the material. The higher the index of refraction, the more reflective the material becomes at all angles, and the Fresnel effect gives us a difference in refraction in different parts of our surface. So the higher the index of refraction is, the less the Fresnel effect will act. So let's adjust our index of refraction to 60, for instance. Here we have a very reflected surface. Now let's adjust it to 2. You can see how unequal all the edges are, especially from the top of the sphere to the bottom. That is the Fresnel effect. Let's now create layers and BSDFs. Layers on the material properties work just like Photoshop layers, and when working with several, it is advantageous to be able to change its opacity levels. BSDF mean bidirectional scattering distribution function, which is essentially a set of algorithms that describe how light interacts with various material types. There are a few tricks with using BSDFs. For instance, to create a plastic, we will need 2 layers with 1 BSDF in each, one that is a clear coat with low roughness and the other which is a base coat with high roughness. Let's now create a plastic. I will use the first material I had created, which is already loaded. First thing I would like to do is add a second layer by right-clicking on my material properties and saying Add Layer. I will rename my top layer Top Coat, and I will rename my bottom layer Base Coat. Plastic works in a way that the first layer is a shiny surface, essentially, and the second layer is what gives its color and its roughness. So for my top coat, my roughness needs to be 0. And my reflectance 0 and reflectance 90 colors need to be black. For my base coat now, I would like to add color to my reflectance 0 and reflectance 90. I'll change my roughness to 95. So for top coat, I would like to change my index of refraction to 1.25 and force of Fresnel. Here we have a plastic, yet our color isn't coming through. Let's now change the weight of our layer to 30% and see that layer blending needs to be additive. It's a bit more plasticky. If I change the opacity back to 100%, here we have a plastic surface. I will now rename it Plastic. To create glass, we will only use 1 layer with 1 BSDF. What makes glass a transparent material in Maxwell is its transmittance color and its attenuation number. This number needs to match the scale of your object, for example 10 centimeters or 30 in this case. On the wizard created glass material, which I'm showing you right now, we can see that it uses a typical index of refraction for crown glass, which is 1.51. Glass also needs really low roughness. In this example, the roughness is 0. We can adjust our transmittance color for tinting the surface, and I will demonstrate this on this wizard created glass material. So select my transmittance color and say I would like to tint it a bit blue. Let's see the preview. If I wanted my glass to be tinted red, I would change my transmittance color to red. The last thing we will talk about in this tutorial is the emitter component of the material. Emitter properties can be defined by 3 types: custom, temperature, and HDR image. With custom, you can select color and luminance separately and have access to a selection of light presets. With temperature, the measurement happens in Kelvin degrees, and much like the physical world, the temperature affects both color and intensity of the light source. With using a high dynamic range image, the image file will emit light from the material surface. This tutorial video covered material creation in Maxwell Studio. Tutorial number 5 will now cover Maxwell Fire and its plugins.